tayo ng math-aral. Sa math, walang maiiwan. Math-sayang math-aral tayo ng math-tuto, upang ika'y umasenso. Maging matyaga, maging matalino, halina math-aral na tayo. Maging matyaga, maging matalino, halina math-aral na tayo. Halina math-aral na tayo. Halina math-aral na tayo. Halina, 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 aral na tayo.
We're done listening to the advanced lesson for Quarter 3, Week 3 of Mathematics 10 CLAID Learning Module. We will now have the advanced lesson for Quarter 3, Week 3 of Statistics and Probability CLAID Learning Module. Our instructor for this afternoon was a graduate of Philippine Normal University, Manila, with a Bachelor of Secondary Education, major in Mathematics in the year 1998. She already have a complete academic requirement for Master of Arts in Education, major in Mathematics in the same school. She is now on her 22nd year in teaching industry. Currently, she is a Teacher 3 in Eulogio Rodriguez Integrated School, Senior High School Department. Batang MANDunong, please welcome Mrs. Elizabeth Luntayao.
Thank you so much for the generous introduction. Good day, Batang MANDunong. Again, I'm Teacher Elizabeth of Eulogio Rodriguez Integrated School. I am with Teacher Jamaica Torres. Join us for today's episode on series of online academic reviews. Tara, tayo ng Math-aral at Math-tuto. Quarter 3, Week 3 of Statistics and Probability is all about probability distribution of a discrete random variable. Today's objectives are: illustrates a probability distribution for a discrete random variable and its properties, and computes probabilities corresponding to a given random variable. Before we start, let's have a short review regarding the two types of random variables. Ano nga ba ulit sila? Tama, they are discrete random variables and continuous random variable. When we say discrete random variables, these are variables that are countable. But when we say continuous random variables, these are the variables that are measurables. Okay, so we have here random variables. They are weight of a newborn baby, number of animals in Manila Zoo, number of COVID-19 patients in the Philippines, normal body temperature of a person, number of cement bags used in constructing a house, and height of a basketball player. Now, I want you to classify these random variables whether they belong to a continuous random variable or a discrete random variable. I'm going to give you a minute to do it. So then again, these are the two types of random variables, the discrete random variable and the continuous random variable. So, you are correct. Under discrete random variable, they are number of COVID-19 patients in the Philippines, number of animals in Manila Zoo, number of cement bags used in constructing a house. For the continuous random variable, we have weight of a newborn baby, normal body temperature of a person, and height of a basketball player. Tama po. Tama po ang inyong mga sagot. So let us start. Probability distribution of a discrete random variable. These are the steps in getting the probability of each value of the random variable. Number 1, determine the sample space. Assign letters that will represent each outcome. Number 2, count the number of the value of a random variable. Capital letters are assigned. Number 3, given the total possible values of a random variable, assign probability values to each value of the random variable. For us to know this better and to understand this, let's have a concrete example. Example number 1. Suppose 2 coins are tossed. Let H represent heads, T represent tails, and X be the random variable representing the number of heads that will occur. Find the values of the random variable X. In our given example, we have an experiment of tossing 2 coins, and we are interested to look for the number of heads. First thing that we need to do is to determine the sample space. We all know that the sample space of tossing 2 coins are head-head, head-tail, tail-head, and tail-tail. Next is to count the number of values of the random variable. Let's make a table. The first column is all about the possible outcomes. And remember, the possible outcomes comes from the sample space. So we have head-head, head-tail, tail-head, and tail-tail. The second column is all about the value of the random variable X. Remember that we are interested to know the number of heads. So for the possible outcome of head-head, we have 2 heads. For head-tail, we have 1 head. For tail-tail, we have 1 head. And for tail-tail, we have 0 head. This time, we're going to count the possible values of the random variable and assign probability values to each value of the random variable. So in a given table, we have 0 heads, 1 heads, and 2 heads. For 1 head, we have a possible outcome of tail-tail, and we only have 1. And remember, there are 4 possible outcomes, so the probability of no heads will be 1/4. For 1 heads, we have a possible outcome of head-tail and tail-head, so there are 2. We have here 2/4, or in lowest term, that is 1/2. And finally, we have 2 heads. And we have a possible outcome of head-head, so we have 1/4. So this time, to make it clear, we're going to have a table out of the given possible outcomes and their assigned probabilities. So the probability distribution of a discrete random variable X is, first row, we have the number of heads, 0, 1, and 2. And then for its corresponding probability on the second row, for 0 heads, we have 1/4. For 1 heads, we have 1/2. And for 2 heads, we have 1/4. Example number 2. Suppose there are 3 people to be tested in COVID-19. Let P represent positive, let N represent negative, and Z be the random variable representing the number of infected person or persons that occur. Find the random variable Z. Okay, this time we are dealing with a 3 persons or 3 people to be tested in COVID-19. We all know that there are only 2 possible outcomes, and that is positive or negative. And we are interested to look for the number of infected persons. So again, let's have its sample space. How are we going to get the sample space? we have two possible outcomes, positive and negative. Then there are 3 people tested. So we have here 2 raised to 3 or 8. So there are 8 possible outcomes. And these are PPP, PPN, PNP, NPP, NNP, NPN, PNN, and NNN. So let us count the number of values of the random variable. So again, we have here a table for the first column is all about the possible outcomes that comes from the sample space and the value of the random variable z. Remember, we are interested to look for the number of infected person or persons, which is represented by letter P. So for the possible outcome PPP, we have 3. For the possible outcome PPN, we have 2. For the possible outcome PNP, we have 2. For the possible outcome NPP, we have 2. For the possible outcome NNP, we have 1. For the possible outcome NPN, we have 1. For the possible outcome PNN, we have 1. And for NNN, we have 0. So as you can see in the given table, the values of the random variable z are 0, 1, 2, and 3. So let's have 0 positive, 1 positive, 2 positives, and 3 positives. For 0 positive, we have a possible outcome of n and n, and that gives us 1. Then we have 8 possible outcomes. So 0 positive, probability value will be 1 over 8. For 1 positive, we have here the possible outcomes NNP, NPN, and PNN. So we have here 3 over 8. For 2 positives, we have the possible outcomes PPN, PNP, and NPP. So we also have here 3, and that gives us 3, 8. And for the 3 positives, we only have 1, so we have 1 all over 8. Again, out of the given data, the probability distribution of a discrete random variable z is first row for the number of infected person 0, 1, 2, and 3, and their corresponding or assigned probability values of the random variable 0 is 1 all over 8. Of 1, we have 3 over 8 or 3, 8. 2 for 3, 8, and 3 for 1 over 8 or 1, 8. Next thing to know are the properties of a probability distribution. So we have here 2. Number 1, the probability of each value of a random variable must be between 0 and 1 or equal to 1 or 1. We can also write here it as 0 is less than or equal to the probability of x is less than or equal to 1. Ibig lang sabihin, ang bawat isang probability ay nasa pagitan lang ng 0 and 1. Pwede rin itong maging equal to 0, pwede rin 1. And then the next property of a probability distribution is that the sum of the probabilities of all values of the random variable must be equal to 1, or we have here the symbol summation of p of x is equal to 1. Ibig sabihin, pag in-add natin lahat ng probabilities of the random variable, dapat our answer is 1. Okay. This time, let us determine if each probability distribution is a discrete probability distribution or not. So we have here 2 tables of probability distribution, the blue one and then the yellow one. Let's start with the blue one. Z has 0, 1, 2, and 3, and its corresponding probability. For 0, we have 1, 8. For 1, we have 3 all over 8. For 2, we have 3 all over 8. And for 3, we have 1 all over 8. Remember that each probability distribution must be between 0 and 1, or it can be 0 or 1. So let's check. 1 all over 8, 3 all over 8, 3 all over 8, and 1 all over 8 are between 0 and 1. So we already satisfies the first condition or the first property. The second property is that when we get the summation of the probability, the answer must be equal to 1. So let's check. Let's add its probability distribution. 1 all over 8 plus 3 all over 8 plus 3 all over 8 plus 1 all over 8. And that is equal to 8 all over 8 or 1. Therefore, we can say that this is an example of a discrete probability distribution. Next is the yellow table. We have here A, and then we have the probability of P of A. So for 1, we have 2 all over 7. For 3, we have 1 all over 7. For 5, we had 5 all over 7. And for 7, we have 1 all over 7. So again, first property is that they must be equal to 0 or 1, or they must be between 0 and 1. 2 all over 7, 1 all over 7, 5 all over 7, and 1 all over 7 are between 0 and 1. So it satisfies the first condition or the first property. The next property is that when we get the summation of the probability distribution, it must be equal to 1. Okay, so 2 all over 7 plus 1 all over 7 plus 5 all over 7 plus 1 all over 7 is equal to 9 all over 7. And it is not equal to 1. So it did not satisfy the second property or the second condition. Therefore, the yellow table is not a discrete probability distribution. This time, we're going to compute probabilities. So the daily demand for copies of a Campus Digest has the probability distribution as follows. For the number of copies, let us represent it as X. You have here 0, 1, 2, 3, 4, and 5. Then for its probability or assigned probability distribution, for 0, we have 0.05. For 1, we have 0.20. For 2, we have 0.1. For 3, we have 0.25. For 4, we have 0.30. And for 5, we have 0.1. We will look or find for the probability that X is equal to 3. And letter B, we will look or find the probability that X is less than 3. So let's have the first one. Find P for the probability that X is equal to 3. Based on the given table, if we have a number of copies of 3 or 3 number of copies, we have a probability of 0.25. So that is our answer. Okay, next, look for the probability that X is less than 3. So what are the numbers here that are less than 3? We have here 2, 1, and 0. So the given are the probability of getting 0 is 0.05, the probability of getting 1 is 0.20, and the probability of getting 2 is 0.10. All we need to do is to get the summation of these three. So the probability that X is less than 3 will give us 0.35. The last one is to find the probability that X is between or equal to 2 and 4. So these are the given. 2 is included, so the probability of 2 is equal to 0.1. The probability of 3 is 0.25. 4 is also included, so the probability of 4 is equal to 0.3. So, get the summation of this, we will come up with 0.65. Again, to wrap up the discussion for today, to get the probability of each value of the random variable, we have the following steps. Number 1, determine the sample space. Number 2, count the number of values of the random variable. And number 3, give the total possible values of the random variable, assigned probability values to each value of the random variable. The properties of a probability distribution are Number 1, the probability of each value of a random variable must be between 0 and 1 or equal to 0 or 1. And the sum of the probabilities of all values of the random variable must be equal to 1. Before we end today's session, I would like to acknowledge Mrs. Amelita Ibanez for her technical support. Thank you also for the trust and support of Mr. Resty Rodelas, our Education Program Supervisor, Mr. Romeo Ibandal, our Principal, Mrs. Cynthia M. Delino, our Math Head Teacher in ERIS, Senior High School Learners, Batang MANDunong. Again, thank you and God bless us all.